In this lesson, we're going to talk about graphing derivatives and first and second derivatives on a graph where you're given a function. It can really play with your head, so we're going to try to approach this from a few different angles. Let's take the linear function that I've given you on the PDF associated with the video first. This thing being a line, well, first we're going to just pick a point, and the point I'm going to start with is the x value of -2. What is the slope of the tangent line to this function at -2? Well, at this point, the slope is 1, actually. You can tell that because it's a line and you can measure its slope. Now, also, you might think to yourself, well, yeah, that's the slope of the tangent line everywhere of this function. And you would be correct. So, for all x values, the slope of the tangent line is 1. This is my attempt at a flat line. And what this blue line is saying is everywhere you are on this function, everywhere, the slope of the tangent line is 1. That's why I've put it at a y value of 1. I'm not sure if you can see that very well, but here's my y value of 1. Okay, now to take the derivative, or the second derivative I should say, we're going to look to our first derivative and examine whether, what the slope of the tangent line is to that. Well, anywhere you are on my blue line, the slope of the tangent line appears to be 0, because the whole line is 0. So, and I asked you to graph that as a dotted line, which I'm doing right here. And if you think about, now let's think about it in terms of increasing and decreasing. This is the process I'd like you to go through. First, do it graphically, and then think, just looking at the graph, increasing, decreasing, concave up, concave down. Well, our graph is increasing always. Our derivative is positive always. Now, is our derivative doing anything? No, but it's positive the whole time, indicating that the graph is increasing. Secondly, our graph is neither concave up nor concave down the entire time. Second derivative is 0 the whole time, so it's not indicating that it's concave up or down. Okay, now these will get a little bit more interesting, of course, as we study different functions. Just going to drag this one over and quickly make sure that you are looking, yes, at what I'm looking at. And so this function, you can see there's a decrease and an increase. So the first thing I'm going to do with this one when I graph the first derivative is I'm going to identify the places at which it is neither increasing nor decreasing, which is an x value of 1. So at an x value of 1, my derivative is 0. And then just find other spots where you can estimate. Now this is not an exact science, but after 1, the function's increasing. Which means after 1, my derivative should be positive of some kind. Now again, it's really, you can't get too perfect with this stuff, but my graph is square, and that looks like it's about a slope of 1. So maybe about here I'm at a slope of 1, because I'm identifying that point as having a derivative of 1. Now, again, just trying to go as close as I can, maybe that looks like it's about 2 or so. So I'm going to go about up here, and now I kind of have at least some kind of trend developing. And it gets more and more steep as you head up. So I feel like that's pretty fair. Now going backwards, I'm looking for a spot that's about -1. Looks like that's about it. So that x value gives me a slope of about -1. And I'm kind of out of room on my graph, but it'll kind of look like this. Now you might think to yourself, why is he connecting this with a line? 2 reasons. 1, I estimated the slope here to be 0. I estimated the slope here to be 1. I estimated the slope here to be 2. And it led me to sort of a linear trend. Reason number 2 is, it's a quadratic. And quadratics derivatives should be linear. Okay, so, and I shouldn't have this going on. This isn't to go on forever, but just up to here. Now when we look at our derivative, which is my blue line here, I want to find its derivative. Well, what's the derivative at that point? Well, we've got to do a little bit of algebraic calculation. Looks to me like I'm going up 1 over a half. So it looks to me like the slope is about 2, right? Or up 2 over 1. If the slope is 2 and this is a line, then the derivative of the derivative, aka the second derivative, will always be 2, and this is my y value of 2. Now let's go back and just get a larger picture of the function. The function decreases, then increases. If it decreases, its derivative should be negative. Oh, I see it, derivative negative. After 1, derivative positive, because the function is increasing. Now let's step back again and look at the whole function from the perspective of the second derivative. The function itself is always concave up, very clear from the picture. Second derivative, always positive, yet another good sign. Okay, so we'll do this again. I'd like you to actually try the the bottom two. Let me just bring them into my screen here. Oh, I should make sure you can see them. Yeah, so now when you look at this, well, you should probably pause here, take a chance at doing both of these, and then play as you need. So the first thing is I'm identifying 2 places where the derivative is going to be 0, here and here. Now, prior to that, it's increasing. Increase, 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 which means my derivative should be positive. So I should be drawing my derivative somewhere up here. Again, not an exact science, but that's very large, less and less. That looks like it's maybe about 1 right there, and 1 is about here on my graph. So, something like that. And again, you're going to have to make some estimates here. So let's just say it does something like this. Now, after that, it decreases. Slowly decreases. Right here, and this is an interesting thing, is right there is its maximum decrease in this little interval. What I mean by that is its tangent line is 0. Now it's slightly negative, slightly negative, slightly negative, slightly negative. But as you hit past this point, my ruler will begin to scoop back up, meaning it's not as negative anymore, the slope. Which means that point must correspond to my lowest derivative in that interval. And it looks to me like it's just about -1. And it's negative, but only slightly. Negative, but only slightly. And it gets more and more and more until down here it's still a negative slope, only slightly. And then it's going to pick back up and hit 0 here as it begins to increase. So I've got a little bit of a picture here. Now, again, is the curvature perfect? No. But I'm doing what we can with this. Now, it increases slightly, okay. It increases a bit more and more and more and more until you get something like that. And that's our first derivative. Now, our second derivative, first of all, we can look at our first derivative and see decreasing, 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 which means from 1/2 backwards, our second derivative should be negative. And then, again, you're going to have to just estimate as best you can. I'm guessing something like that. Now, how did I know to hit right here? Well, the second derivative, or the first derivative, happened to be pivoting from decreasing to increasing there, which means our second derivative, which is the derivative of the first derivative, produces a flat line. And then from there, it heads up. And of note, if you now step back and look at the original function to check the first derivative with it. First derivative, well, the function increases, positive, 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 0. Then decreases from there to there. And our derivative was negative that whole time. Then the function increases and our derivative is positive. It's not about whether or not the derivative is going up or down. It's about, is the derivative positive? That'll tell you about the original function. Now the second derivative, let's look at the original function in the context of the second derivative. To me, it looks like where this red point is a pretty clear point of inflection. Concave down? Oh yes, the second derivative is negative. Concave up? Sweet. Second derivative is positive. And I'm going to leave the last one for you to investigate. But what you can always do too is try to think of functions that mirror that behavior if possible, and then take their derivative and see what goes on. But the major thing is identifying where first derivative is 0, or second derivative is 0, etc., and then going for positivity and negativity from there. It is a confusing process, but it's one that is very enriching to to deepen your understanding of how derivatives work, how graphs work, and how they interrelate. Okay, thank you.